So from this hazard curve, we can identify which city is which city has a higher seismic risk level. So as I mentioned, the amount of airborne chloride attenuates with the distance from coastline, as does seismic intensity, such as when peak ground acceleration attenuates with the distance from seismic source. So in addition, airborne chloride amount depends on wind speed and the ratio of sea wind to land wind. So to obtain the hazard curve associated with airborne chloride, we can use similar equations to those used to obtain seismic hazard curve. So again, probabilistic density function of wind speed and the ratio of sea wind are used. In addition, attenuation rule is needed in this equation. So this is one example of attenuation rule associated with airborne chloride. So you can see the amount of airborne chloride attenuate with the distance from coastline like this. So this figure shows the hazard curves associated with airborne chloride for Sakata City and Uwajima City in Japan. So the ratio of sea wind to land wind and wind speed are very different in these cities. So this results in different risk level of chloride attack. So anyway, to establish maintenance strategy, it is very important to consider the differences in marine environment using these hazard curves. However, in this hazard curve, random variables are only sea wind, the ratio of sea wind to land wind and wind speed. So for advancement of hazard assessment associated with airborne chloride, the effects of coastal topography, structure geometry, wind, rain, and humidity on airborne chloride spread need to be investigated. So finally, I present life cycle reliability estimation of concrete bridges. So to estimate the life cycle reliability of concrete structures, we have to follow these steps, including hazard assessment associated with airborne chloride, as I mentioned, estimation of time to steel corrosion initiation, estimation of time to cover cracking initiation. So many random variables need to be taken into consideration. So the statistics of these random variables can be quantified based on the experimental results or surveys of existing marine concrete structures. So as I explained, hazard assessment associated with airborne chloride use two random variables, wind speed and the ratio of sea wind to land wind. And calculation of the time to corrosion initiation, time to corrosion crack occurrence, steel weight loss due to corrosion. So we have to use so many random variables. So, however, once observation information are provided, such as crack widths and chloride concentrations, the statistics of these random variables can be updated to be consistent with these observation information. So probabilistic density function can be updated like this based on inspection result. This is an inverse problem. However, generally, inspection result relate to many random variables. In addition, relationship between observation physical quantities and random variables are nonlinear. So theoretical approach is impossible to implement. So now there are several methods to identify the parameters using inspection result. However, I think most strict method is sequential Monte Carlo simulation. Some researchers called this method as particle filter. So today I don't explain that I will not explain the detail of sequential Monte Carlo simulations. If you are interested in this method, please check our papers published in engineering structures. This paper provides details of procedure of sequential Monte Carlo simulation. So I present illustrative examples. So now I assume RC slab is located in Wakkanai City. Wakkanai City is here. Okay. And we assumed that at 30 years after construction, we can obtain the crack widths of ranging between 0.2 millimeter and 0.5 millimeter from visual inspection. And also, at 30 years after construction, chloride concentration are provided by quarrying test, like this. This figure shows the cumulative time failure probability and time relation. So due to the chloride-induced corrosion, the failure probability increases with time, like this. However, at 30 years, observational information as crack width and chloride concentration is provided. So using these inspection results, failure probability drops so drastically, like this. So this figure shows the samples used in general Monte Carlo simulations before updating. So before updating, we need to consider very large uncertainties. However, once inspection result is provided, random variables can be updated to be consistent with the inspection result. So as a result, the variability, the uncertainties can be reduced like this. So reduced uncertainties can cause the decrease of failure probability like this. So today I will present some researches relating to this framework. I hope you have some interest in my research field. So thank you very much. Thank you for your kind attention. in sequential Monte Carlo simulation. So this is samples used in general Monte Carlo simulations. So in sequential Monte Carlo simulation, we update each samples based on like Bayesian updating. Do you know Bayesian theory? So sequential Monte Carlo simulation use Bayesian approach. So when we update random variables, so we update each sample based on Bayesian theory. Okay? So as a result, mean value and standard deviation and probabilistic density function distribution are changed. Okay.
Yeah. The last speaker before the break, our break, is Professor Sato from Hokkaido University. Okay. Professor Sato, he got his master and PhD from Hokkaido University. His research experience he doing on concrete structure for 17 years. He's an expert on computational mechanics of the concrete structures, and now he's moving his interest to durabilities mechanics. So, ladies and gentlemen, please welcome Dr. Sato.
Thank you, introduction. Yes, the maybe title of my talk today is a new approach for the performance assessment of RC and the severe climate conditions. So, I mean, today I'd like to explain about the what we are doing now to solve the to estimate the life cycle or the actual performance of the structures. So, in fact, my talk is really very strongly related to the Professor Nakamura's talk. So that's all. Please allow me to start from the background of my research for today's talk. So maybe no need to explain about these deterioration mechanism. There are several types of the deterioration mechanisms: corrosion and carbonation, and fatigue, and the chemical erosion, and freeze-thaw cycle, and ASR, something like that. But at the design stage, we don't expect such a deterioration in the concrete structures. I mean, let's compare the design stage and maintenance stage. So at the design stage, let's say it's a fantasy world. I mean, we have to predict the reaction of the structure against the design mechanical action and the design environmental action. But to evaluate it, we have big assumption. So no deterioration takes place in the structures. But as you can see here, in the real world, we have several damage in the actual concrete structures because the structures would be suffered under the actual mechanical action and the actual environmental action in the real world. So as a result, unfortunately, the deterioration takes place in the real world. To solve this discrepancy between the design stage and maintenance stage, maybe we have to change the design concept feature. But we already have such damaged structure and infrastructures. So we have to solve, or we have to make an answer for the issues. So to do that, yes, let's say the current index, which can link fantasy world and real world, probably the diffusion question D. So you know, the most serious deterioration mechanism is the corrosion, of course. If we can avoid the corrosion of the river, maybe we can use the structure as long as possible. So that's why we want to check the corrosion would occur or not using the diffusion question, D. But yes, the diffusion question D itself, of course, cannot explain the actual performance of structures. So here you can see the capacity of the RC member, and this is time. So there are the possibility. So sorry, this dotted line represents the required level. So if the actual performance is over than this line, it's okay, safe, of course. And here, intersection point represent its lifetime, or something like. So, okay, anyway, we have the possibility. A, linearly reduced, or B, I don't know, the gradually reduced, and C, the rapidly and quickly reduced at certain, which is the correct one. So A, B, no, action one is C. So, okay, before that, I have to explain that this one. There are so many performance required for the structures, safety performance, or serviceability, and aesthetics. So when we think about the hierarchy of this performance, of course, most important thing is the safety, and then serviceability and aesthetics. And if you have so much money and so much the human resources, then okay, no problem. You can make a very beautiful structure, right? You can make construct a very strong or nice structures, but in Japan, maybe as well as this country, so our budget is really limited. And of course, when we look at the national road, maybe we can put a certain amount of the money for the maintenance, but the city road or village, what's happened? So no money, no human. So that's why we cannot keep the enough aesthetic or serviceability performance. We have to really think about what actual safety is. So this is, in fact, the real meaning of the importance of the performance assessment of damaged structures. So of course, as I said, okay, let's compare with the appearance. So here, this is a capacity of RC member. For example, fracture capacity and the shear capacity doesn't matter. At the beginning, okay, in case of the freeze thawing action, so the popping out would take place, but the performance of capacity does not change, of course, and bigger spalling would be taken like that, but no capacity reduction, and maybe such a severe damage together with the corrosion of the river, then the capacity will be reduced like that. So we have to predict this stage. So of course, if we can control up to this level, the diffusion coefficient is enough. But we cannot do the preventive maintenance. We have to have the prediction method to predict to determine the actual performance or capacity here. So to do that, yes,